we are going to construct a continuous, so we're not going to have any vertical asymptotes, continuous graph from the number lines. And what they're going to give you in the book is just the first derivative part and the second derivative part. I highly recommend you copy the number lines down and add the top row to the number line graph. This is what you're going to see. F prime of x. So we are going to have, let's see, 1, 2, 3, 4. At 1, you might see an EP. That stands for end point. It doesn't continue beyond that. It starts there. 2, infinity or undefined. 3, we've got a 0. And then nothing at the 4. In between, I've got a positive here. So that means the first derivative is positive between 1 and 2. Then it switches to a negative between 2 and 3. And then it's negative after the 3. So because there's nothing here to stop it, it's negative all the way as it goes past 3, 4, 5, whatever. So that's what you're going to see in the book. I highly recommend you copy that down, and then you add the top row here. Because you need to sketch a function for f, so we need to know what's going on. So endpoint, I don't know what that is yet. But here, this positive, if the first derivative is positive, I know my function is increasing. If it's negative, I know it's decreasing. Well, let's stop and think. It's going up, and then it's coming back down. So I know there's some kind of a max here, but the derivative is infinity or undefined. Well, what kind of a max has an undefined first derivative? That's a cusp. So this max has to be a cusp. And now I'm going negative to negative. So the concavity didn't, or not the concavity, the direction didn't change. It's decreasing before and after the critical point. So that makes this a plateau. And it's got to be a horizontal plateau because the derivative is 0. If it was undefined, it would be a vertical plateau. So this is a horizontal plateau. Okay, so this endpoint, because it's going up, must be a minimum. So add that row into your table. The second table will also only give you the second derivative information. Leave a row for the function because we're going to fill that in. We're going to keep this one simple. We're going to have the same 4 values here. 1, 2, 3, 4. Again, we've got that endpoint on the second derivative. If it's infinite there, it's infinite here. It's undefined, undefined. 0 stays 0. Here we've got a positive second derivative, and then a negative second derivative. So remember, the second derivative tells us the concavity of the original function. So between 1 and 2, my function is concave up. Between 2 and 3, I'm concave up. So that means there's no point of inflection here. Now I've got concave down. So that does make 3 a point of inflection. Okay, now we've got to sketch this thing. And these get to be very challenging. So 1, 2, 3, 4. Leave yourself some space in here to actually draw it, otherwise it's kind of hard. Great, take it chunk by chunk. So at 1, I've got an endpoint. It doesn't tell me whether it's positive or negative. I don't care, so I'm just going to pick a point. Now do one chunk at a time. From 1 to 2, I know the function is increasing and it's concave up. So it's increasing with some concavity up. So it's not linear. I got to have concave up and increase. Can it be flatter than that? Yes. So I just need the concavity going up. At 2, I know I've got that cusp happening. So I'm going to have that sharp change in direction. So from 2 to 3, I'm decreasing, but still concave up. So decreasing, I got to come down, but have concave up. So down, concave up. So that has that concave up, and it's decreasing. At 3, I know I've got that horizontal plateau. So now 3 to 4 and beyond, I'm going to decrease concave down. So here I'm going to decrease concave down. And there it is. Now that horizontal plateau, it kind of sounds like it's got to have some distance through there, but just the concavity switch itself is what gives you a plateau. So don't worry about having a big flat spot through there, because 3 is only at the one spot there. So that's what you need for a horizontal plateau, is just the point where it's going to switch. And there it is. Let's try one more of these that's a little more challenging, where these don't actually line up perfectly like this one does. Oh, I called that example 1. That's all right. Okay, here's our first number. Again, you're going to want to copy these number lines down so that you can fill in the top row yourself. So this will be blank. It won't be filled in. This one, we're going to go from -3 to 3. So -3, -2, -1, 0, 1, 2, 3. The derivative is going to be 0 at -3, 0 at -1, 0 at 3. And before -3, its derivative is negative. This whole interval, it's positive. From -1 all the way to 3, it is also positive. And then after 3, it's going negative. So, what does that tell me about the original function? Take the time to do this. A negative derivative means it's decreasing, because we want to know what's making this derivative be 0. It's either a max, a min, or a horizontal plateau. We're going to find out right now. Now the derivative switches to a positive. Well, if the graph goes down and comes back up, and I actually have a derivative of 0, I know it's a minimum and not a cusp. So it's a nice smooth min. Jump over this. I'm still going up. Here I'm still positive, up again. Because the derivative is 0, your choices are 3. Max, min, plateau. I've got to have a plateau because it doesn't switch. So horizontal plateau. And then I'm still increasing, but then I decrease. So if I was increasing and then decreasing, derivative is 0, I know I've got a max here. Okay, the second one. F of x, you can fill it in. F double prime of x will be all given to you. Keep the same values here. This time at -2, the second derivative is 0. I'm going to put the numbers in here. -3, -1, 0, 1, 2, 3. Between -2 and -1, oh no, I got a 0 here. And then I got a 0 at here. 3 spots on the second derivative. Okay, before the -2, the whole second derivative is positive. Negative in here. Positive. And then negative. Okay, second derivatives indicate concavity. So up until -2, this thing is concave up. And again, above each one of these is either going to be a point of inflection or no point of inflection. That's all we've got for options here. Here it's concave down. So this is a point of inflection. Here it's concave up. This is a point of inflection. And then here it's concave down. So that makes this a point of inflection. All right. Sketching ones like this where the critical points are not lining up. Well, there's one where it lines up, but the other ones are not. They're a little more challenging. Oh, gotta go to negative 3. Let's see. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Alright. So, we start chunk by chunk. Our first critical point is at negative 3, and I know I've got a minimum. So I'm going to put my point, doesn't matter where. So before the negative 3, I know I'm decreasing and I'm concave up. So decreasing concave up looks like this. Now I go from this critical point, and the next one on the number line is happening here. So I'm only going to draw the chunk from negative 3 to negative 2 because that's my next critical point. Well, from negative 3 to negative 2, it's increasing and it's still concave up. So increasing, concave up. Then the next critical point is from negative 2 to negative 1. I'm still increasing, but I'm switching to concave down. So that makes this that point of inflection. So increase, concave down, looks like that. And then the next chunk, see I did this, the next critical point is at 2. So from negative 1 to 2, the whole function is concave up and increasing. So concave up and increasing all the way to 2. Concave up, increasing. And then 2 to 3, we are concave down, but still increasing. So switch the concavity, still increasing. And then after 3, that's our last critical point, I know it's a max, it's concave down and decreasing. Okay, there was a lot going on. You got to take it from critical point to critical point, piece by piece, and all you care about is concavity and direction. You can do these. Okay, your assignment is page 362, 1 through 18. I know the notes are really long, but the homework isn't too long. All right, stop this.